All right, in Chapter 6, the first two sections were on exponents. For the Chapter 6 review, I'm going to start with an example on exponents. First thing you always want to do in exponents is power to a power property. So that means I'm going to take a to the negative first, b to the negative 1 times negative 1, which would be b to the first. Then we're going to multiply that with x to the negative first, all over y to the negative 1 times negative 1 is y to the first. Z to the 2 times negative 1 is z to the negative second. Now I'm going to multiply straight across. In the numerator, I get a to the negative first, x to the negative first, all over, multiply straight across. B to the first is just b, y to the first is just y, and then I have z to the negative second. My last step on these exponent problems is going to be to flip any of the negatives or to combine any of the a's, x's, y's, and z's in the numerator and denominator. A needs flipped, x needs flipped, and z needs flipped. So my final answer is going to be z to the second when I flip it. A is going to go to the denominator, so I'm going to have a to the first. B is going to stay down there. X is going to go to the denominator, and y. That would be my final answer. Circle that for exponents. After exponents, we quizzed on factoring. So a couple different factoring problems. One factoring problem might be factoring a cube. So y to the 6 plus 27. We're going to factor this. Anytime we see a binomial or two terms separated by addition or subtraction and they're both perfect cubes, we're going to factor a cube. So this is factoring cubes. Now, the cubed root of y to the 6 is y to the second. So I'm going to rewrite this as y to the second to the third, and the cubed root of 27 is 3 to the third. So first thing I always do is I rewrite these in factoring form. Now cubes, I always have a small parenthesis and then a large parenthesis. My signs are either positive, negative, positive, or negative, positive, positive, which means I have two positives, one negative. I always start with the same sign I started with in the original problem. So in this problem, I'm going to start with positive, so I know my signs are positive, then negative, then a positive. Now, my bases go in the first set of parentheses, and what's left of the first and second term go in the first and the last set of parentheses in the large. So my bases here are y to the second, and 3 is also a base. How many y's do I have left? Well, I started with 6 and I used 2, so I have 4 y's left. How many 3's do I have left? Well, I have 2 3's left, so we're going to write that as 3 to the second, or 9. And to get my middle term, I multiply my bases together. So 3 times y squared would be 3y squared. That's factoring a cube. If we stay with the factoring idea here, we're going to factor something like this. Let's do a perfect square trinomial, which would be n plus 3 squared minus 8 times n plus 3 and then plus 16. So we're going to factor this. This is a perfect square trinomial. That means that the first term and the last term are both perfect squares, and my signs are both going to end up being the same when I factor them. Those are the general rules of a perfect square trinomial. I look at the back term to see what they're going to be. Well, positive back term means that they're both going to be the same. The middle term tells me what they're both going to be. In this case, they're both going to be negative. And then all I have to do from here is take the square root of the first and the square root of the last. The square root of n plus 3 squared is just n plus 3. And the square root of the last is 4. For my final step, I simplify inside the parentheses, and I get n minus 1. 3 minus 4 is negative 1, and n minus 1. And that's factoring a perfect square trinomial. Kind of an ugly perfect square trinomial. One last factoring problem we might look at is a grouping problem where I have 4 terms. We'll start off with x squared plus 6x plus 9 minus 49 w squared. So anytime I see four terms and my directions say to factor, I know that this is factoring by grouping. First thing I look at is I see in the first three terms or the last three terms if I have a perfect square trinomial. And in this problem, I do have a perfect square trinomial. To factor a perfect square trinomial, we're going to end up with something squared. So square root of the first, square root of the last, the signs are both going to be the same. The middle term tells me they're both going to be positive. Square root of x squared is x, square root of 9 is 3. Now I just drop down what I have left here, this negative 49 w squared, and here I have a difference of squares. Another special one that we might see on the test. In a difference of squares, I know my signs are different. I take the square root of the first and the square root of the last. So the square root of x plus 3 squared is x plus 3. And the square root of 49w squared is 7w and 7w. And that is my factoring with grouping perfect square trinomial into a difference of squares. The last type of problems we might look at deal with multiplying exponents. An example of one of these problems might be something like x to the n times x to the n plus 1 minus 3 x to the n plus 5x plus 2. This is just a normal distribution problem, and what we want to do is we want to take this x to the n to the first term, x to the n times x to the n plus 1, and our rules say that when we multiply powers of the same base, we add the exponents. So when I take x to the n times x to the n plus 1, I have x to the, keep the base the same, add the exponents, n plus n is 2n, and then I just have plus 1. I'm going to do the same thing with this x to the n and that negative 3, x to the n. So negative 3, x times x, keep the bases the same, add the exponents. N plus n is 2n. And my final, I take x to the n all the way over to this, oops, I got two more, to the 5x first, plus 5x times x, bases stay the same. If I do not have a variable, then that's just x to the first. So we're going to add the exponents, n plus 1, we cannot combine those, so we're just going to have n plus 1 right here. My final term, all the way over, x to the n times 2 is just 2x to the n. And these ones are our complicated exponent problems where we have to be really careful. We remember that when we multiply powers of the same base, you keep the base the same, add the exponents. And if you want to, you can think of these as 1x to the n, 1x to the n, because you multiply the numbers times the numbers, keep the bases the same, and add up the exponents. Be careful only to add when there are like terms. Just when there are like terms. All right, the last problem we'll look at is a multiplying problem. It's a foiling problem, multiplying a binomial by a trinomial. So a minus b times a squared plus ab plus b squared. When we're multiplying this binomial times a trinomial, we do the same sort of thing where we distribute the first term to every term in the second, then we're going to distribute the second term to every term in the second. A times a squared is a to the third. A times ab would be a positive a squared b. A times b squared, just a positive ab squared. Now we come to this negative b, and I do the same thing to every term in the next one. Negative b times a squared is negative. I'm going to go ahead and keep my a squared first. Just always write them in alphabetical order so I can tell easier at the end how to combine them. Negative b times positive ab is negative ab squared. And negative b times a positive b squared is negative b to the third. Now to finish this problem, I combined all my like terms. A squared b minus a squared b, those are going to cancel out. AB squared minus AB squared, those are going to cancel out. And I'm just going to be left with a to the third minus b to the third. And that's my final answer. This has been a review of Chapter 6. The things that were not included in this review are long division and synthetic division. They were quizzed over last class, so I'm hoping that we have a good, solid concept of those going into this test. If anybody needs more help with factoring, make sure you come see me before the